G'day. One of the major parts of the Taylor Hobson rotary fixture is the turntable. Now, originally this is cast. I elected not to do that for a number of reasons. I didn't believe that I could get such a fine grade of cast iron easily. And so, as well as making up the patterns and the cost and all that sort of thing, I decided I could make it more easily by fabricating it out of steel, as I've done here. This isn't finished. I haven't put the graduations on because I'm going to be grabbing onto this to put the thread on the base here and reduce that diameter and possibly even put a hole through the middle. So it's sort of a part finished thing, but it all went swimmingly until it didn't, and so this is the story of you know, how to make up one of these and also how not to make up one of these. Originally this part was cast. I'm going to fabricate it because I could cast it, I guess, but I would prefer something out of steel. I know what it is then, and it's certainly easy to get. So the first thing I'm going to do, I've got a blank here. It's an offcut of about 170 diameter, so I need to take that down a little bit in size and also take it down in thickness. Now that's black, so one of the first things I'll be doing, as I did in a previous video, was basically face that off and then clean up the edges. To do that, some of you may have seen this, some of you may not, but this is what I use when I'm setting things up in a forge or with a dial indicator. It's basically a dial indicator in a little bracket sitting in a quick change tool holder, and I just find this far more easier. I can move that back and forth to do than getting a magnetic base and putting on there. I also don't like magnetic bases too much on machines around steel because they tend to pick up shavings and swarf and all that sort of thing. So if I can avoid magnets on things like this, I will. Here's the disc, a whole lot of turning later. The original has a step in, so it's only running on the outside of the disc, so I've put that in there. I've also put a bore in here for a piece of round to go in and a bit of a step. So the idea is I'm going to turn this the opposite feature on a bit of bar stop, push that in there, then I've got a bit of bevel here I can run around with some weld. I can do the same there, and fingers crossed I'll have a nice rigid structure. I'm not going to turn this down until I get that welded in there, in case it moves when I weld, and then I'll clock it up again like this, pop a centre in and do all the turning down and threading and that sort of thing I need to do here. It is tempting to put it between centres, but the trouble with a disc like this is that it's going to act as a big flywheel, and so it could wobble around and do all that sort of stuff. So probably in a forge jaw like this is as good as I'm going to get. I've now machined up my spigot. So this part here is about a 1/2 thou interference with this bore here. This one here is size for size. I've got a chamfer there and a chamfer there and corresponding ones here, so once this is all pressed together I can then run around with the welder and just put a small bead there just to lock everything up. Once I've got that, I can then mount that back up in the chuck with this bit sticking out and clean it all up and all the rest of it. I'm using a rule of thumb that was given to me by a friend Phil, who said allow 1 thou of interference per inch diameter, and that seems to work quite nicely for those who are interested. It's an S fit, but what I'm going to do is basically clock this up in the lathe, centralise it all, turn this down to 50 millimeters or 2 inches, whichever one I'm going to use, probably 50 millimeters, and then what I'll do is flip that over and clean that up. I'm then going to try and put the T-slots in, I think, simply because it's a convenient spot to do it. I can hang on to a shaft here without having to worry about damaging threads. I may come along and put the divisions on then, or I may wait till I've done this bit. I'm not quite sure about that one. It's another one of those, you know, advantages, disadvantages, because if I put the divisions on there, when I come to grab that in a chuck to put the thread on, I could damage those divisions. But if I put the divisions on after I put the thread on, I now need to work out how to hold this So it's 6 one, half dozen the other. I did eventually go to 50 millimeters for that, and I'll put on an equivalent thread to the thread that was on the original in terms of its pitch. As you see, I've got a weld around here, and that's slightly recessed. Now this table runs on this surface, and so that's the contact surface it's going to be in contact with that's the surface that's going to be in contact with the cast iron. So I've just set a depth stop so that the end of my cut there is 0.5 millimetre, 20 thou, underneath this surface, and that should be fine. On the original there's a groove, but that's because that's one piece, you can do that without any problems. I've put a centre in there because I feel a little bit more secure with the centre, and at least I'll have one now that's concentric with this. So this surface should be concentric with this one, that centre should be concentric with the axis of everything. I can now flip it over and just clean up the welds on the front there. This is one of those awkward setups where I had to get concentricity on this surface as well as get flat, have a flat plane here. So it was a matter of dialing that in, then putting an indicator there, tapping the low spots. When that's at a low spot, tapping on the opposite side to try and lift it up and skew it. It took me 3 or 4 goes, but I finally got there. And so what I've done is I've just taken a very light skim across here to try and clean up the weld. You can see the shiny spot there where the weld is a different material, different hardness to the rest of it. That's okay. This centre section was slightly high anyway. It hasn't cleaned up too badly. The only thing is a small spot there where the weld has not quite been cleaned out. I'm not going to put any more weld on that, and I don't think I'll take another skim of it. It's just going to, I'm just going to have to live with it there. But I do have to put a trench in there for the T-slot, so it might be one of those spots where the T-slot is, and it just wipes out that low spot. Everything else here is pretty good. I'm now going to put on some concentric rings. This one, as you can see, has got rings. They're a 1/4 inch apart. It's probably a little bit too fine for my liking, but I do find they are handy for trying to get things lined up. So the way I'm going to do that, this is my internal thread cutting tool, and I'm just going to use that because it's got enough tip relief there that I should be able to get a groove in there. Shape of the groove doesn't matter too much. That should be fine. And I'm not quite sure what I'll do. I'll probably do something like 10 millimetre increments or something like that, perhaps 1/2 inch, just to mark things out. This is the point where I confess to things going pear-shaped on me. The way I secured this was I used a V-block on the back of the part there, and then put that into the vise. Now that works nicely for small parts, but for larger parts like this one, as I've discovered, it doesn't. I started off doing the slots fore aft, and that was all fine, but the problem with going acrossways here is that there's a lever arm involved, and so it doesn't take much to tilt that, and that's where things went wrong. And so the cutter grabbed, flicked the part out of the vise, and I came unstuck. And you can see here where it's stepped down. Now, I went on to complete this part and finish off the T-slots and things like that, and you'll see that very shortly with a different way of clamping that. I put it up onto some 1, 2, 3 blocks, but then I decided, well, I'm going to have to remake this part because I'm not happy with that, and even patching up, I'd know it was there. So So I then went in and made another part like this top, but this time I put the T-slots in there first. Then I put a spigot in, welded that in. And so you'll see that as well. Yes, I'd like to say it can happen to anybody, but no, it can't happen to anybody. It just happens to people who are a bit overconfident in their methods. So it's a lesson for me. That's how it goes sometimes. This is the setup I've finally used for putting the T-slots in. I did have it in another setup, and in the vise with the V-block on the stalk there, and that just didn't work. It let go. I'll have to salvage this piece or make it again, but I thought I'd just carry on with the T-slots to make sure this worked. I've got the 1, 2, 3 blocks. I've actually got 4 of them here, but I've got them set up so that they're, you know, perpendicular to each other, just so that if it gets a good shunt one way, it's not going to, you know, collapse and all that sort of thing. I just finished putting the T-slots through my revised table. With this table, I put the shaft in and then welded that, and then machined the T-slots and the features on the top of the table. With the revised version, I've gone and put in the T-slots and done all that sort of thing, and that's come out quite nicely. I've now got a recess there. I've machined up a stub shaft, and I'm now going to push that in, and the interference is going to be on the large diameter, and then just run around with the welder here, and also on these little pieces here. Something important to note, I guess, is that because I've already got this relieved out, if I go for an interference fit on this diameter here, which is the attractive one because it's the longer one, I could end up splaying this table out. So instead I've had to go for the interference fit. It's only a couple of thou on the larger diameter. This is basically a size for size fit in here. I'll push that in, a couple of tacks up here just to hold everything, weld around the base, then come back and finish up the top, and that should give me basically that same assembly. This I haven't taken down to size. This is just I think it's about 55 and it'll come down to 50. I just want to get this in and round about right. Once that's all done, I can then chuck that up and turn that down to whatever size it's going to be and do all the other things to it. I've now welded on those 4 spots and around there, and then dressed that back and taken that down to 50 millimeters. So that's now perpendicular to this face and concentric with this diameter. That's about all I'm going to do for this at the moment. At some stage I need to put a thread in here and I need to step that down, but until I have the casting machined, I won't be doing that, and until that's done I won't be putting the graduations on around the outside here. Not a big step, but just one of those things that until everything falls into place, you know, why run the risk of scuffing up markings, numbers, whatever, by rushing these things. A tale of 2 tables. This one here done as per the casting with the spigot on there, but due to poor clamping, I had to redo, and so I did this one in a different way. But it also shows usually there's more than one way to do something, but you need to think about it a bit. So anyway, I've certainly learned a few things during this. I hope you have too, and you know, thanks for watching. We'll see you for the next one.